What's up, you freaking geniuses? So in this video, I'm going to teach you how to find the linear speed of an object that's traveling in a circular motion, all right? So the problem up here just says the second hand of a clock is 10.2 centimeters long. All right, so looking at the clock over here, it obviously tells us that this hand right here, the seconds, is 10.2 centimeters long. Now we want to find the linear speed of the tip of the second hand, all right? So we want to find the linear speed of this point right here, right? The tip of the hand as it passes around the clock face. All right, so as it goes all the way around. All right, so the formula that we want to use to find the linear speed of an object that's going around in a circle is V is equal to S over T, where V stands for the linear speed, S is the arc length, and T is the time. All right, so let's plug in what we know. So we don't know what the linear speed is yet, right? So that's V, and that's going to be equal to S over T. So how do we find S, the arc length? Well, remember, in order to find an arc length, we can simply use the arc length formula, which is S is equal to R times theta, where again, S is the arc length, R is the radius, and theta is the central angle. So when we're talking about the tip of this second hand, we know what the radius is, right? Because let's draw that path that tip goes on, right? So it goes around somewhere, something like that, okay? So what is the radius of this orange circle that we just drew, right? Because again, that's the path that this little point takes, right? Well, the radius would be what's given, 10.2. So the radius right here for the arc length, we're gonna plug in a 10.2 centimeter right there. And then what's theta? Well, again, that's the central angle. Okay, so as you can see, this is where we start with the second hand, right? And then we go all the way around and then we stop basically back to where we started, all right? So that's what theta is in our case. So what is this angle right here? Well, in order to go around an entire circle, that's 360 degrees. Or if we're talking about radians, that would be 2 pi radians, all right? So let's plug in 2 pi for theta right here. And then lastly, we just have to find the time. So how long does it take for the second hand here to start here, go all the way around, and then get back here? Well, that would take 60 seconds, right? So our time is going to be 60 seconds, all right? So now that we kind of filled in the blanks here, let's plug in what we know now. So first of all, to find the arc length, let's just write that down here. We're gonna say that S is equal to 10.2 centimeters times 2 pi. So here, 10.2 times 2 is 20.4. So then the arc length is going to be equal to 20.4. And then don't forget, we still have our pi right there, right? Pi, and our units are centimeters. All right, so that's the arc length. And then we're going to divide this by the time, which again is 60 seconds, all right? So again, V is equal to S over T, right? So then here, we're going to say V is equal to S over T. So now if you plug this into your calculator, 20.4 pi divided by 60, you'll get that V, the linear speed, is equal to, we're going to say approximately 1.07. And what are our units? Well, we have centimeters over seconds, right? Centimeters per second. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.